Hi everyone, this is Dr. B. Koteswar, working as assistant professor from Marri Laxman Reddy Institute of Technology and Management. So today I'm going to discuss about a topic from Internet of Things. The topic is IoT enabling technologies. So IoT enabling technologies. So what are the IoT enabling technologies? The IoT enabling technologies are wireless sensor network, cloud computing, big data analytics, communication protocols, embedded systems. So, what is IoT and what is IoT enabling technologies? Simply, IoT refers to collective network of connected devices and technology that facilitates communication between devices as well as between devices and cloud. That is nothing but IoT. Okay. So, if IoT is there, some enabling technologies are there to support IoT, to strengthen IoT, to provide high security to IoT. Some enabling technologies are there. So, these technologies will strengthen IoT. So, the technologies are wireless sensor network, cloud computing. Okay. So, this is wireless sensor network. Okay, and this is cloud computing, and this is big data analytics, communication protocols, and embedded systems. These are the IoT enabling technologies. Because of these technologies, we are using IoT in various applications because of these technologies only. Otherwise, we are unable to use IoT. Okay. So first one is wireless sensor network. So what is wired and wireless network? Wired means we know that there is a wired communication between two devices, and wireless means there is no communication path. There is no wired connection between two devices. Wireless sensor network. This wireless sensor network consists of some end nodes and one router will be there. Router and coordinator node and coordinator node. Coordinator node will be there. So these are the end nodes. These are the end nodes. This one are the end nodes. Here these end nodes consist of. So wireless sensor network is one of the enabling technology for IoT. Now I am going to explain about the architecture of this wireless sensor network. Okay, this consists of end nodes. One is end nodes, router, coordinator node. So what is the role of this end node? These end nodes consist of sensors. Internally consist of these sensors. End nodes consist of sensors. Sensor will collect data from the surrounding environment. Sensors will collect the data from the surrounding environment. Okay, and it will pass it to the router. So, what the purpose of router? Router will transfer data from this end nodes to coordinator node. What is the purpose of this router? Router will transfer data from this end nodes to coordinator node. Okay, what is the role of this coordinator node? This coordinator node will collect data from router and it will transmit to the cloud. So this is the architecture of wireless sensor network. So distributed devices with sensors used to monitor the environmental and physical conditions. So distributed devices with sensors which are available in end nodes will gather surrounding data and physical conditions. And the coordinator node collects data from all nodes, acts as a gateway that connects wireless sensor network to the internet. So this is the coordinator node. This coordinator node collects the data from all the nodes, and it acts as a gateway. It acts as a gateway and connects this wireless sensor network to the internet. It will connect this wireless sensor network to the internet. So overall, wireless sensor network consists of end nodes, router, coordinator node. What is the role of coordinator node? It will collect data from all the nodes and it will connect the data from all the nodes and it will connect this wireless sensor network to the internet. The router will transfer data from end nodes to coordinator node. What is the role of these end nodes? End nodes consist of sensors. These sensors will collect the surrounding data. Okay, this is the wireless sensor network, which is one of the enabling technology in the IoT. Because of this wireless sensor network, by using this wireless sensor network, okay, this one collect the data, surrounding environmental data, and it will, through with the help of internet, it will transfer to the cloud. So from the cloud, users, human being can access data with the help of mobile, okay, from the cloud. So we are getting weather reports in our mobile apps because of this wireless sensor network and interconnected with IoT. So example, weather monitoring system, indoor air quality monitoring system, soil moisture monitoring system, surveillance system, health monitoring systems. The protocol used is Zigbee. Coming to the second enabling technology is cloud computing. What is a cloud? Cloud also plays an important role to strengthen the IoT. Okay, what is cloud? Cloud is nothing but a data center. Cloud is nothing but a data center. On rental basis, it will provide rental basis, it will provide storage and network. So cloud computing. Okay, this cloud computing consists of deployment model and service model. What are the deployment models? Public cloud, hybrid cloud, private cloud. You have to know what is public cloud, private cloud, and hybrid cloud. So public cloud means which every human being can access this one. Every human being. For example, YouTube, everyone can access. If you have internet connection, everyone can access YouTube. That is example for public cloud. What is private cloud? Private cloud means the cloud can offer some space or some storage to the companies. So few companies, they are keeping their data in the cloud. Okay, only those company authorized person can access data from the cloud, because it consists of some ID and password will be there. With the help of password only, they will get data from the cloud. That is secure. Normal human being cannot access data from the cloud. That is nothing but private cloud. So overall cloud, some part of data is available to all the human beings. Some part of data is not available to all the human beings. Only it is available to only few persons only, authorized persons only. It will be high secure. And hybrid cloud is combination of public cloud and private cloud. Service models: infrastructure as a service, platform as a service, software as a service. It will provide three types of services. Coming to the public cloud, one example is bus. Everyone can use bus. Private cloud, our own vehicle. Only that authorized person only can access. Hybrid cloud, taxi. Okay. So if you pay the money, we can use this one. This is about difference between public, private and hybrid cloud. So coming to types of service models, already we have discussed infrastructure as service, platform as service, software as service. Okay. If your business needs a virtual machine, option for infrastructure as a service. So if your business need any computers, virtual machines is nothing but a computer here. More number of computers is required. Virtually we can use that computers from the cloud. Virtually, not physically. Virtually we can use computers from the cloud. So that is nothing but infrastructure as service. Platform as a service. If your company requires a platform for building a software product, so any software product you need, cloud will provide that, so those software. That is nothing but platform as service. If your business does not want to maintain any IT equipment, then choose software as service. Example for the software as service is MS Office, MS Word. Okay, already that is designed by the cloud. We are utilizing those services. Next, another enabling technology is IoT enabling technologies, big data analytics. Big data analytics. So what is big data? The data which we cannot store, we cannot process, we cannot analyze is nothing but big data. What is big data? Big data is nothing but the data which cannot store, we cannot process, we cannot store, we cannot analyze is nothing but big data. Collection of data whose volume, velocity, variety is is too large and difficult to store, manage, process, and analyze the data using traditional database. So by using traditional databases, we cannot store when we cannot analyze the data. That is nothing but big data. So here volume, velocity, variety is means these are the characteristics of data which are very high. Volume is very high, velocity is very high, variety is also very high. It involves data clean, cleaning, processing, and visualization. Lots of data is being collected and warehoused. Web data, e-commerce, purchases at department, bank, credit card transaction, social network. These are the examples. This is about the diagram. So for the clear understanding of big data analytics. Okay. Here ATM machine is one example. Okay. Some examples of big data generated by IoT systems are described as follows. Sensor data generated by IoT systems such as weather monitoring stations. So weather monitoring stations consist of sensors. Those sensors will collect surrounding data from the environment. So that data is nothing but big data, because every minute, every hour, every second, that surrounding environmental conditions will change. Every second it will change. Every 10 seconds, every 1 minute it will change. So when it is changing, data is changing. That is nothing but that is example for big data. If we take 1 day data, 1 day consists of 24 hours. Each hour consists of 60 minutes. 1 minute consists of 60 seconds. So in 1 minute, so many times it may changes. Okay, environmental condition changes. So every time we are collecting data with the help of sensors. Okay, with the help of sensors. So the data continuously changes. That is the example for big data. Machine sensors data collected from the sensor embedded in industrial and energy system for monitoring their files in protecting failure. This is also an example. And health and fitness data generated by IoT devices such as wearable fitness band. For example, whatever the watches we are wearing, digital smart watches, so it will collect the data. Okay, it will give the surrounding environmental condition data. It will give, okay, whatever the data IoT smartwatch is giving, that is also big data. Data generated by IoT system for location tracking of vehicles. So for the now we are using vehicles. So the option provided in the vehicle is location tracking option will be there in the latest vehicles. So location tracking, so many times we are tracking the location of the vehicle. So that the data is nothing but big data. Data generated by retail inventory monitoring system also one of the example for big data. Next, one of the enabling technology of IoT enabling technologies communication protocols. So communication protocol form the backbone of IoT systems and enable network connectivity and coupling to applications. And the communications protocol allow devices to exchange data over the network. So what is a protocol? Protocol means set of rules between transmitter and receiver, so that data can be transferred 100% accurately. If there is no protocol, there is no rules between two devices, okay, we will not get 100% data from the transmitter to receiver. Accuracy will be less. This protocol defines the data exchanging formats and data encoding schemes for devices and routing of packets from source to destination. So these protocols will define data exchange formats and data encoding schemes for the devices and routing of packets from source to destination. When we are transferring packets from source to destination, it will define data exchange formats. And other functions of the protocol include sequence control, flow control, and transmission of lost packets. So when transmitter will transmit data, receiver will receive data. If transmitter transmitting 10 packets, the receiver receives only 8 packets. Okay, so it will resend another 2 packets. It will resend the missing 2 packets the transmitter can resend. This is about communication protocol. And last one is embedded system. This is also one of the enabling technology for IoT. So embedded system. Embedded system is the combination of software and hardware. Embedded system is the combination of hardware and software. It also one of the enabling technology which strengthen IoT. which strengthen the IoT. An embedded system is a computer system that has computer hardware and software embedded perform specific tasks. So combination of hardware and software which can perform specific tasks. For example, ATM machine. It consists of hardware. Internally, some coding will be there. Programming is done internally. ICs are programming. Uh, so this is the combination of software and hardware to for the specific purpose, for the withdrawing of money we are using. In contrast to the general purpose computers are personal computers which can perform various types of tasks. Embedded systems are designed to perform specific set of tasks. Example, embedded systems include microprocessor, microcontroller, adapter, input output unit, display, keyboard, memory, RAM and ROM, cache memory, networking units, storage such as flash memory. Some embedded systems have specialist process such as a digital signal processor, DSP, graphic processor and application. So the embedded system consists of RAM and ROM, input, output, microprocessor and microcontroller, networking units, storage such as flash memory. So these are the 5 enabling technologies which will strengthen IoT. Okay. So in this class we have discussed about what is IoT, what are the IoT enabling technologies, and in detail about IoT enabling technologies. So IoT refers to collective network of connected devices and technology that facilitates communication between devices and cloud as well as between devices themselves. So IoT enabling technologies are big data analytics, communication protocols, embedded systems, and cloud computing, wireless sensor network. Wireless sensor network. So we have discussed about this wireless sensor network. We have discussed, and cloud computing we have discussed, and big data analytics we have discussed, and communication protocols we have discussed, and embedded system we have discussed. These are the 5 enabling technologies which support IoT. Thank you.